Hello everybody, welcome. So we are entering into our fourth module of EST 100 Engineering Mechanics. Fourth module is about dynamics. So as per your syllabus, you have the following things to learn: dynamics, rectilinear translation, equations of kinematics, kinetics, equation of motion, D'Alembert's principle, motion on horizontal and inclined surfaces, motion of connected bodies, impulse momentum equation and work energy equation, curvilinear translation, equations of kinematics, projectile motion, kinetics, equation of motion, moment of momentum principles and work energy equations, concepts only. See, two things it is given as a review, that is equations of kinematics review and projectile motion review, because these things you have already studied in your school, in your 12th standard or 11th standard so far. So we will have a review of this concept and we have to solve certain problems also. Then two things, concepts only, so problems probably not necessary, impulse momentum equation and work energy equation, and the work energy equation for curvilinear motion. For these both probably concepts only is needed. So entering into our module 4. Module 4 is basically about dynamics. Not only module 4 and module 5 is about dynamics. Module 1, 2, 3 was about statics. 4 and 5 is about dynamics. So in our very first class we saw what is statics and what is dynamics. So statics is the mechanics dealing with the particles at rest, objects at rest, and dynamics, the mechanics dealt with it is the particles when it is in motion. So our first part is our basics, what we have to learn in our module 4 is about dynamics. So what is dynamics? So statics, we all know it is the study of the mechanics of when the body or the object is at rest. Dynamics, it is the branch of mechanics. So mechanics, we all know, we apply the laws of nature, laws of mechanics. Laws of mechanics we know, it's Newton's laws, Newton's first law, Newton's second law, Newton's third law, gravitational law, sine law, etc. So these are the laws of mechanics. Mechanics you can find everywhere in the nature, everywhere. And when we apply this concept of mechanics for engineering, we call it as engineering mechanics. So here it is, dynamics is the branch of mechanics which deals with the motion of particles or bodies under the action of forces. So dynamics means motion, when the particle is in motion. And when a particle needs to move, there should be some force applied to it. Only when a force is applied, the particle starts to move. So dynamics comes when we apply a force. So once you apply a force, the body starts moving. Even after the removal of the force, the body still be in a moving state for a while, for a short duration. Then it will come to rest if we are removing the force. So the motion of the body after the removal of the force, we call it as free motion. That is, force will be equal to 0. Force is removed. Now, this dynamics is classified into kinematics and kinetics. So we have already learned what is kinematics and what is kinetics. We know the definition. So kinematics, the forces are not considered. Forces responsible for causing the motion is not considered. Kinetics, forces responsible for motion is also considered, that is kinetics. So kinematics is the study of motion of bodies without reference to the forces which cause the motion. So there is some force is responsible for the motion, but we do not consider the force causing the motion. That is called kinematics. Kinetics is the study of bodies with reference to the force which cause the motion. So forces responsible for the motion is also considered. That is called kinetics. Now some basic things about kinematics. So the forces are not considered. Now it is the study of the geometry of motion. So what do you mean by geometry of motion? So nothing but relating displacement, how much it is moved. What about the velocity, acceleration, trajectory motion? So these are called geometries of the motion. These are the things required to define the motion of a body. So kinematics is used to relate the displacement, velocity, acceleration, trajectory motion and time without reference to the forces causing the motion. So we relate these things. We relate the displacement, velocity, acceleration. Normally displacement, velocity and acceleration with respect to the time. So examples are motions such as gears and connecting rods, etc. So there is some mechanism. So without the application of force, initial force will be applied and after that you can it will run of its own. So these are all the examples where the law of kinematics or the equations of kinematics or principles of kinematics will be applied. Now, kinematics. So kinematics is the study of bodies with reference to the forces which causes the motion. So forces are also considered and it is the study of relationship between the forces acting on the body. So we have seen that in our first class. We saw that the forces, we know that Newton's second law is force is equal to mass into acceleration, and Newton's third law, every action has an equal and opposite reaction to be in equilibrium, right? That means whenever an external force is applied, an internal force is developed to resist this external force. So that is the relationship between the forces. So the relationship between the forces, external forces and internal forces, is used in kinetics. So example is in the jet propulsion. So we will study this while doing the problems. Right? Now, before going to the next part, so dynamics basics is over. Dynamics is classified into kinematics and kinetics. Kinematics, the forces are not considered. Kinetics, forces are also considered. Now, our second part is rectilinear translation. According to our syllabus, it is rectilinear translation. So before going into rectilinear translations, we should know what are the different types of motions. So first of all, we will define the motion. So a body is said to be in motion if it changes its position with respect to a reference point, with respect to some reference point. The type of motion is defined by the path traversed by it. So how it travels, how the body or the object is traveling. According to that, the type of motion is defined. So what are the different types of motion? So we have translational motion and rotational motion. See, in general, the motion is classified into translational motion and rotational motion. Translational motion, it moves in a straight path. Rotational motion, it moves with respect to some center. It will be a curvilinear motion, it will be an angular motion. So rotational motion is a path. For rotational motion, the path is a concentric circular about the center. So for example, we can take the moving of a tire or like that. So with respect to the center and with respect to a angle, the angle changes and the movement is made. Movement of the object is made with respect to some point, with respect to some angular moment, angular moments. So it is concentric circular. So we call it as rotational motion. It rotates. All the objects undergoing rotational motions comes under this rotational motion. Now, translational motion, it moves in a linear motion, linear way, or in a curved manner. So when it is moving in a linear path, we call it as rectilinear translation. When it is moving on a curve, we call it as curvilinear translation, and these both are linear translations. That is why we call it as translations. Linear, both are linear. So here for rectilinear translation, the path travelled by the object will be a straight line. For curvilinear translation, the path is a curved line. So another third case is there, that is general plane motion. Normally we call something as a plane motion when it is a combination of both rectilinear and curvilinear translation. So it is a combination of both rectilinear and curvilinear translation. We will call it as plane motion, general plane motion. So we have seen that the type of motions are translational motion and rotational motion. And the translational motion is further classified into rectilinear motion and curvilinear translation. So types of motion is one part. And the second part is dynamics. So dynamics is kinetics and kinematics. So we have studied two different things. We saw two different things, dynamics and motion. Now relating these both is our fourth module. So our fourth module, we will divide it into four parts. So fourth module, we have to study the kinematics and kinetics. Kinematics and kinetics of rectilinear translation is our fourth module. Kinematics and kinetics of rectilinear and curvilinear translation is our fourth module. Kinematics and kinetics of rotational motion is our fifth module. So as I told earlier, this fourth and fifth module is about dynamics. So dynamics, that means dynamics is nothing but kinetics, combination of kinematics and kinetics. So kinematics and kinetics of translational motion, that is kinematics and kinetics of rectilinear motion and curvilinear motion. That is our fourth module. Kinematics and kinetics of rotational motion is our fifth module. So our fourth module, we have to study the kinematics of rectilinear motion, kinetics of rectilinear motion, kinematics of curvilinear motion and kinetics of curvilinear motion. So the applications of these four concepts is our fourth module. Okay. Now we will go for part 1. So we have four parts: kinematics of rectilinear motion part 1, kinetics of rectilinear motion part 2, kinematics of curvilinear motion part 3, kinetics of curvilinear motion part 4. So we are going for part 1, kinematics of rectilinear motion. Now what is rectilinear motion? So the path travelled by the particle will be a straight line. I repeat, the path travelled by the particle will be a straight line. Here, this is the particle. This P is the particle. So this particle is moving from P to P dash. So this particle is moved for a distance of, yes, this is called displacement. This particle P has moved from this part to this part in a straight line, and the total distance traveled is the displacement, the shortest distance between the initial and final position is called the displacement. And at a time t, you can see at a time t, this is the origin. So from the origin, at a time t, the particle is in p, and from p to p dash, for reaching here, the time taken is dt. And the shortest distance between the initial and final position is called displacement. Now, kinematics of rectilinear translation. So what are the things? See, we are not going for the derivations, just a review and the application of the review. We have already studied these things in your schools. In your schoolings, you have studied in your basic physics. So, kinematics of rectilinear translation, just we will review it. We will recall what we have studied and we will apply it for solving the problems for our engineering applications. Velocity displacement, it is the shortest distance. Now, velocity is defined as the rate of change of displacement. So, velocity is rate of change of displacement, that is ds by dt. S is the displacement and t is time. So, ds by dt. Unit is meter per second. And if the velocity is constant, then the motion is called uniform motion. Uniform motion, the velocity is constant. Now, acceleration is defined as the rate of change of velocity. Rate of change of velocity. Velocity is changing. Then we have acceleration, and acceleration is dv by dt, rate of change of velocity with respect to time, and the unit is meter per second square. And this acceleration can be acceleration or deceleration. For deceleration, a is substituted by minus a. Deceleration. If the acceleration is reduced, we call it as deceleration. Now, the other equations are when it is in horizontal motion and when it is in vertical motion. When an object is in horizontal motion and when the object is in vertical motion. When the object is in horizontal motion, our basic equations for kinematics for rectilinear motion for constant acceleration are v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as, and s nth is equal to u plus a by 2 into 2n minus 1. So, u is our initial velocity. U is our initial velocity. V is our final velocity. V is our final velocity, u initial velocity, a is our acceleration, and t is the time. S is the displacement. Now, S nth is the distance travelled in the nth second for a particular second. Nth second for particular second. Fifth second means just a fifth second. Now, for vertical motion, V is equal to, we replace this A by G. A is for horizontal motion, for acceleration. G is when it is falling down or going up. Acceleration due to gravity. This is A is horizontal acceleration. G is acceleration due to gravity, that is vertical acceleration. So, V is equal to U plus GT. H is the height. H is equal to ut plus half gt square, and v square is equal to u square plus 2gh. And g is positive for downward motion and negative for upward motion. If the ball is thrown upwards, for upward motion, we take g as minus. Okay, that's all the basics of kinematics of rectilinear motion. So, we saw what is dynamics, what are the different branches of dynamics, what are the different types of motions, then the basics of kinematics for rectilinear motion. Now, based on the kinematics of rectilinear motion, we will solve problems. So, first problem is a motion of a particle is described by an equation, displacement. Displacement, equation for displacement is given. S is the displacement. So, S is equal to 5t square minus 7t plus 2. We are asked to find the displacement, velocity and acceleration when time t is equal to 2 seconds. Part B, minimum displacement and corresponding velocity and acceleration. Take S in meters. So, S displacement is taken in meters. We want to find velocity, displacement and acceleration at time is equal to 2 seconds. Then, minimum displacement and corresponding velocity and acceleration. Minimum displacement. At minimum displacement, what is the corresponding velocity and acceleration? That means, what is the minimum displacement? When minimum displacement takes place. And at that time, when there is a minimum displacement, what is the corresponding velocity and acceleration? Okay, so first part, for time t is equal to 2 seconds, we are asked to find the displacement, velocity and acceleration. So, displacement, the equation is given 5t square minus 7t plus 2. Substitute t is equal to 2 seconds. We get displacement as 8 meter. Then, velocity is ds by dt. Velocity is ds by dt. Differentiate displacement with respect to time. We get 10t minus 7. Substitute t is equal to 2 seconds. We get 13 meter per second. Now, acceleration is dv by dt. Differentiate the velocity with respect to time. So, we get 10 meter per second square. Now, we will go for the second part. Okay, this is our second part. We were asked to find the minimum displacement and the corresponding velocity and acceleration at minimum displacement. So, our first aim is to find what is minimum displacement. So, you have already studied in your basic mathematics. When you need to find the minimum or maximum of a function, we need to differentiate it, and that will be equal to 0. Differentiation, first derivative is equal to 0 in order to find the minimum or maximum of a function. So, here it is minimum displacement. If it is minimum displacement, differentiate displacement with respect to time and equate it to 0. That is what we have done here. So, we are differentiating the displacement and equating it to 0. So, we know ds by dt is v. So, v is equal to 0. Now, equating the velocity is equal to 0, we get time t is equal to 7 by 10 seconds. So, at time t is equal to 7 by 10 seconds, you will have the minimum displacement. So, for t is equal to 7 by 10 seconds, our displacement is minus 0.45 meter. So, that is equal to 0.45 meter. Displacement is always positive. It is a scalar quantity. So, displacement, even it is minus, we will take it as the absolute value. It is 40.45 meter. Velocity is equal to ds by dt. So, substituting, we get it as 0. And acceleration is dv by dt, it is 10 meter per second square. So, putting both part A and part B, first part and second part together. That's all problem 1. We will go for problem 2. So, this is your problem for your practice. I will explain how to do, you have to solve it. So, a motion of a particle is defined by S is equal to 2t cube minus 6t square plus 15, where S is in meter, displacement is given in meter, time is in seconds. Determine the position and acceleration when the velocity is 0 and velocity is minimum. So, two conditions. When velocity is 0, what is the position and acceleration? When velocity is minimum, what is the position and acceleration? Okay, for velocity is equal to 0, See, first of all, find S is given for you. So find what is velocity, ds by dt. So substitute that is equal to 0. V is equal to ds by dt is equal to 0. Find what is the time. So for that particular time, your velocity is 0. So for that particular time, find what is the displacement. Yes, you will get 7 meter. What is the acceleration? Find the acceleration for that particular time. You will get acceleration is equal to 12 meter per second square. Now the second part is velocity is minimum. So for the velocity is minimum, your condition is you have to differentiate it. Differentiate the velocity. That is dv by dt is equal to 0. That is acceleration is equal to 0. dv by dt is acceleration, that is equal to 0. So now find what is t. When acceleration is equal to 0, find what is t. You will get a t as 1 second. So at 1 second, your s will be equal to 11 meter and velocity will be equal to minus 6 meter per second, and acceleration already it is equal to 0. This is your second problem. Now problem 3 is the position of a particle which moves along a straight line is defined as s is equal to t cube minus 6t square minus 15t plus 4. S is given. Displacement, equation for the displacement is given. And where s is expressed in meter and t in seconds, determine time at which the velocity is 0. So first part, determine the time at which velocity is 0. Second part, the position and distance travelled by the particle at that time. Third part, the acceleration of the particle at that time. And fourth part, the distance travelled by the particle when t is equal to 4 to t is equal to 6 seconds. From 4 to 6 seconds, what is the distance travelled? Now, see, first part is time. Determine the time at which velocity will be equal to 0. So find the velocity, substitute it equal to 0, you will get a time as minus 1 and 5. You will get two values, minus 1 and 5, and time cannot be negative, so time is 5 seconds. Now second part, find the position and the distance travelled by the particle at that time, that is at t is equal to 5 seconds. For this time, t is equal to 5 seconds, you have found out this. So for t is equal to 5 seconds, what is the position? So yes, at t is equal to 5 seconds is, it will be minus 60 meter. Now distance travelled will be equal to, see, it is travelling from time as t is equal to 0 to 5 seconds. 0 to 5 seconds. That is why the distance travelled up to the 5th second minus distance travelled in the 0th second. That is starting displacement, final displacement minus the starting displacement. So you will get minus 100 meter. So distance travelled cannot be negative, it is equal to 100 meter. Now what C is the acceleration of the particle. So at t is equal to 5, substitute in the formula for acceleration, we will get acceleration is equal to 18 meter per second square. Next is distance travelled when t is equal to 4 to 6 seconds. So 4 to 6 seconds. So there is a 2 seconds. From 4 to 6 seconds we have 2 seconds. Now our formula is from 4 to 5 seconds. 4th second to 5th second, what is the distance travelled? From 5th to 6th second, what is the distance travelled? So substitute Sn. What is the distance travelled in the 5th second minus distance travelled in the 4th second plus distance travelled in the 6th second minus distance travelled in the 5th second. You will get the answer. So problem 4 is an automobile travels 360 meter in 30 seconds while being accelerated at a constant rate of 0.5 meter per second square. Determine its initial velocity, its final velocity, the distance travelled during the first 10 seconds. So this is our given problem. We will draw the diagram first. This is our initial velocity. At this moment we will have the final velocity. this automobile, this vehicle has travelled from 0 to 360 meter and the total time travelled is 30 seconds. So S is 360 meter, time is 30 seconds. Now initial velocity u, we have to find the initial velocity u. So substitute in this formula, S is known for us, T is known. So we get u equal to 4.5 meter per second. Acceleration is also given as 0.5 meter per second square. So substitute value for A as 0.5 meter per second square. Now for B, find the final velocity is equal to u plus at. U is taken as this value. So you get 19.5 meter per second, and C is the distance travelled during the first 10 seconds. So substitute T is equal to 10. In the equation S is equal to ut plus half at square. We get S is equal to 70 meter. Thank you. So this is your work today. I hope you all understood up to this. We will continue this part tomorrow. So if you have any doubts, you can ask or you can comment on this section. Thank you once again. Thank you.